Question 8. Randomly choose two numbers between 0 and 1. What is the probability that their mean is no greater than 2/3? This is a probability question. You might think about strategies that related to probabilities. For example, maybe we can try complementary. It asks no greater than 2/3. We can try greater than 2/3, right? But it doesn't help. And their mean is no greater than 2/3. Equivalently, we can ask if the sum is no greater than 4/3, but that doesn't work either. Why do the strategies that typically work for probability problems not work here? This is because here we are looking at continuous random variables. We call it continuous because if you look at each of the numbers, each of them is between 0 and 1. So what are the possible choices for each of them? It can be anything between 0 and 1. It could be 0.0001. It could be 0.99. It could be 1/3. It could be square root 2/2. So there are infinitely many choices. So that makes it pretty difficult to solve the question. For a problem like this, we typically try geometric probability, which is a strategy to solve these kind of problems. Let's use the x and y coordinates to represent the two numbers. Let's say that x represents the first number and y represents the second number. So each of them is between 0 and 1. And now if we draw the square, this gives us the places of the pairs of x and y that are allowed, right? Because both of them need to be between 0 and 1. And we notice that the question is their mean is no greater than 2/3, which means the sum is less than or equal to 4/3, right? So let's look at the straight line x plus y equals 4/3. So here, let's say this is a 4/3. This is a 4/3. If we connect them, this is x plus y equals 4/3. What we want to know is that within the square, but below this line, this gives us all the pairs of x and y such that x plus y is less than or equal to 4/3, and x and y they are both between 0 and 1. So as long as we can find the shaded area, then we know that the total area of the square is 1. We know the probability. So let's look at what some critical points. This one, x equals 1, is on the line, which means that y equals 1/3. This point, y equals 1, and x plus y equals 4/3, which means that x is 1/3, right? So we have a right triangle, and the length of one leg is 2/3. The other leg also has length 2/3. So the area of this triangle is 1/2 times 2/3 times 2/3, which is 2/9, which means that for the shaded area, it is 1 minus 2/9, which is a 7/9. The total area of the square is 1, thus the probability is, so this is typo, it should be 7/9. Problem 9. For how many positive integers n less than or equal to 1000, 2n minus 1 is divisible by 7? Let's look at the first few positive integers. 1, 2, 3, 2n minus 1. When n is 1, 2n minus 1 is 1. When n is 2, we have 3. When n is 3, we have 7. When n is 4, we have 15. When n is 5, we have 31. When n is 6, we have 63. We are looking for divisible by 7. So this is multiple of 7. This is multiple of 7. Correspondingly, we have n equals 3, n equals 6. We see a pattern. N needs to be a multiple of 3. N needs to be 3, 6, ... until 999. Altogether, there are 333 numbers. So it seems that the choice should be C. Now let's confirm it by using modular arithmetic that we introduced in problem 5. If you don't remember modular arithmetic, please go back to problem 5. Okay, so if n is a multiple of 3, let's say that is 3k, then 2n can be written to 2 to 3k, which is 8 to the k, right? We know that 8 and 1 are congruent in mod 7. And then by the exponent rule, if we look at the kth exponent, they should also be congruent in mod 7, which means that 8 to k and 1 are congruent in mod 7. And this is also 2n minus 2n and 1 are mod in mod 7. 2n and 1 are congruent in mod 7 if n is a multiple of 3. But recall that 1 and 1, of course, they're congruent in mod 7. If we do subtraction, we have 2n minus 1 and 0 are congruent in mod 7, which implies that 2n minus 1 is divisible by 7 when n is 3 times k. So this confirms that as long as n is a multiple of 3, then 2n minus 1 is divisible by 7. A 23-9th number is a positive integer that equals 23 times of the sum of its digits. Let n be the smallest 23-9th number. What is the difference between the largest digit and the smallest digits of n? We don't know the number of digits that n has. So let's try 2-digit. And let A be the 10th digit and B be the unit digit. By the definition, we know that the number n has to be 23 times the sum of the digits, which is 23 times A plus B. And clearly, this is greater than 10A plus B. But this is n. We see that it is not possible for it to be 23 times of the sum of the digits. Thus, 2-digit doesn't work. Let's look at 3-digit. We want to find the smallest one. If 2-digit doesn't work, we look at 3 digits. Let A, B, C be the 100th, 10th, and unit digit, respectively. By the definition, we have 23 times the sum of the digits. It should be the same as the value of n, which is 100A plus 10 times B plus C. We can rewrite this equation to 13B equals 77A minus 22C, which is 11 times 7A minus 2C. We see that 13B has to be a multiple of 11. 13 is not a multiple of 11. So B has to be a multiple of 11. But B is between 0 and 9. The only way that 13B is a multiple of 11 is that B is 0, right? Once we know that B is 0, we know that 7A minus 2C is also 0. Because A and C, they are unit digits, they have to be that A is 2, C is 7. Thus, N is 207. The largest digit is 7, the smallest digit is 0, and the difference is 7. Okay, so we're done with this question. You might be curious that how many 23 nice numbers there are. Okay, let's look at 4 digits. And let A, B, C, D be the digits. Then by the definition, 23, A, B, C, D, the 23 times of the sum of the digits. But we notice that this one is less than 23, less than or equal to 23 times 36, because A, B, C, D are numbers between 0 and 9. And if you multiply them together, this is less than 1,000. But we are looking at a 4-digit number. It has to be at least 1,000, which means that 4-digit doesn't work. And similarly, you can see that more digits won't work. So 207 is not only the smallest, but also the only 23 nice number. Problem 11. We have ABC, an equilateral. The side length is 1. BCD is an isosceles right triangle with D equals 90 degrees, which means that CBD is 45 degrees. DCB is also 45 degrees. But recall that ABC is an equilateral, which means that each angle is 60 degrees. Thus, we have an ECD 15 degrees. This is also 15 degrees. Okay. Next, we look at ABD and ADC. ABD and ADC. They share AD, and BD and CD are the same because BD and CD are the same because they're the two legs of an isosceles right triangle. And AB and AC are also the same because they are the two sides of an equilateral. This tells us that ABD and ADC, they are congruent, which means that each of the angle is 30 degrees. BAD is 30 degrees, and also DAC is 30 degrees. Okay, next, let's look at AED, this angle, AED. This is an exterior angle of triangle CDE. An exterior angle equals the sum of the opposite interior angles, and we know that both of them are 15. Therefore, AED is 30 degrees, right? Now we see that ADE is an isosceles triangle, which means that AD and DE are the same. AD and DE are the same. Next, let's look at the CDE. It is also an isosceles triangle, which means that DE and CE are the same. So this tells us that CE equals AD. CE is not very easy to compute directly, but if we look at the AD, it's much easier. So let's see how we can do that. So for AD, we notice that it is part of the height of ABC when we use BC as the base. So this is the midpoint of BC, and this part is 1/2, which means that the height of BDC is also 1/2, and the height of ABC, we know that the side length is 1, and the BP is 1/2, so the height is √3/2. Thus, AD equals square root over 2 minus 1/2. And this is also the length of CE. So D is the right answer. Problem 12. 7 positive numbers, a1 through a7 in non-decreasing order. The mean, median, mode are all 7. What is the largest possible value of a7? Let's write the numbers one more time. A1, A2, A3, A4, A5, A6, A7. Let's try to see which numbers are fixed. The median is 7, which means that A4 is 7. There's no other choice for A4. 7 is the only number. We also know that the mean is 7, which means that the sum of the 7 numbers is 7 times 7, which is 49. Okay. We want to find A7. We want to find the largest possible value, but the sum is already fixed, which means that we want the other numbers to be as small as possible. Because they are in non-decreasing order, A4 is already 7, so the smallest possible number for A5 is 7. For A6 is also 7. And for A1, A2, A3, they are all positive numbers. So ideally, all of them should be 1, right? But we notice that if we have a 3 1s, 3 7s, then the mode is not a 7. So for that, because of that, we have to increase A3 slightly. We add a 1 to that. So with that, this is the smallest possible way that we can this is the way that we can make the other numbers as small as possible. And they add up to 4 plus 21, which is 25. A7 equals the sum, which is 49, minus the rest, the sum of the rest. So the answer is 24. 24 is the largest possible value of A7. Problem 13. ABCD is a square on the coordinate plane with A, 6, 0, B, 0, 8. If the lines 3y plus 4x equals k bisects ABCD into 2 congruent rectangles, what is k? So for this line, a lot of time it's easier if we rewrite it into the format of slope and intercept. Now you notice that the slope is the same as AB, which is also the same as CD, because it is the same, so they're parallel with each other, right? We want to find the one that bisects ABCD such that you have 2 congruent rectangles. Thus, this line, the y equals negative 4 over 3x plus k over 3. This one, you can find the intercept first. An easier way would be look at a specific points that it passes, okay? So which point? You can use the center of the ABCD, or you can just look at AC or BD. Either one works. So let's look at the midpoint of AC. So let's look at the ABO triangle. OA is 6, OB is 8. The hypotenuse is 10. This is a special right triangle. The ratios are 3 to 4 to 5, right? And AC is 10, right? So the shorter leg, so this one, it should be 6, and the longer one should be 8, which means that the coordinates of C is 14 and 6. Now, the midpoint of A and C can be computed easily, right? Because A is 6, 0, C is 14, 6. Thus, the midpoint, let's call it M. M is 10 and 3, which tells us that the line must pass the midpoint, else the two rectangles that it displays cannot be congruent. So if we plug in the midpoint of AC into this one, it should work, which means that 3 equals negative 4 over 3 times 10 plus k over 3. Let's multiply 3. We have a 9 equals negative 40 plus k, which means that k is 49. As I said, once you notice that the line is parallel to AB and CD, then you just needed to find a point that it passes. And for example, the midpoint of AC equally easy. You can look at the midpoint of BD. You can also use the center. It's a little bit more complicated because you need to find all the 4 points. If you try to find the intercept, you are going to work on some triangles or ratios. But anyway, so probably I think it takes practice to find the easiest way. For this particular problem, use a midpoint of either AC or BD seems to be the best choice. The following is the divisibility test for 8. A 3-digit number ABC is divisible by 8 if NA plus 2B plus C is divisible by 8. Okay, let's look at N. Let's look at this number ABC. It equals 108 plus 10 times B plus C. We want to know whether it is divisible by 8. So what we can do is that first we separate the parts that we know for sure that it's divisible by 8. And then we can ignore and just focus on the rest of 8. Okay, 108, we can take out a multiple of 8. The largest multiple is 96 times of A. Then we have 4A. Then from 10B, we can take out 8 times B. Then we have 2B left, and then C. So now let's put the parts that are divisible by 8 already. This one, and then we have 4A plus 2B plus C. If you look at the first group, 96A plus 8B is already divisible by 8. So we just need to know whether the second group is divisible by 8 or not, which is exactly what this test is doing. By matching them, by comparing them, we know that N is 4. So the answer is 4.